Hey, it's Ashley from Smart Edition Academy. In today's video, we're going to go over some Accuplacer QAS practice questions. So this is the quantitative reasoning, algebra, and statistics section of the Math Accuplacer exam. So if you are taking that test coming up and you want some practical examples of what you will see on the test, this is the video for you. Before we jump into it, check out the link in the description of this video for more practice questions of the other topics that you will see in the Accuplacer, as well as our full online course and free practice tests. Okay, so let's jump into this. We've got a few topics to cover today. So here's a list of some things you might see in the QAS section. So each of these bullet points are topics that we are going to go over an example of in our video today. So just an idea of what you might see. So the first topic is rational numbers. Okay, so rational numbers, we have fractions, decimals, whole numbers, integers. Okay, all of these are rational numbers. Technically, a rational number is any number that can be written as a fraction, and that includes non-terminating, non-repeating decimals. Those are all irrational numbers. So anything that has a repeating decimal can be written as a fraction. Those are our rational numbers. So here's an example of something you might see in this topic. Simplify the following expression by reducing completely and then convert the fraction to a decimal. So this is going to practice some of our operations as well as going from a fraction to a decimal. So -4 minus -5 all over 5. So the first thing we want to do is -4 minus -5. We want to simplify that. So when we subtract a negative, what we're actually doing is we are adding. So we're just doing -4 plus 5, which is 1. 1 over 5 is a simplified fraction. Now to turn it into a decimal, the fraction bar really just means division. So we're just going to do 1 divided by 5, and if we plug that into our calculator, 0.2 would be our final answer. So turning this into a decimal, we get 0.2. Okay, so you also want to be really comfortable converting from fractions to decimals, decimals to fractions, working with percents. You can see more of those types of questions in our arithmetic video. So let's look at some examples of rational and proportional relationships. So this is talking about ratios. So here's an example of something you might see. A recipe calls for 2 cups of water and 3 cups of flour. If I want to use 8 cups of flour, how much water will I need to use? So here's a very practical example. If you're doing a recipe, this is something you might need to know. So to turn this into a ratio, 2 cups of water to 3 cups of flour, we can write that with the colon, 2 to 3. Or in order to help us do some arithmetic with this, it's a little bit easier if we write this as a fraction, 2 over 3. So we just want to remember that on top we have the water, on the bottom we have the flour. So in a recipe and in any ratio, it needs to stay equivalent. So if I want to use 8 cups of flour, I still need to use the same ratio. So these are going to be equal. So what I'm going to do is I'm going to put an X for the water because I don't know how much water I need. That's what I'm trying to find. And then I will put the 8 cups of flour down on the bottom because that's where the flour goes. So from here, what I need to do is I need to cross multiply and try to solve. So 2 times 8 gives me 16. And then I have 3x. So 16 equals 3x. In order to find what that x is, I can just divide each side by 3. So 16 divided by 3 as a decimal would give me 5.3 repeating. Okay, but that's not really helpful in terms of a recipe, right? You don't have like a 0.3 repeating measuring cup. So it's really helpful to know that this 0.3 repeating is the same thing as 1/3. So this is really just 5 1/3 cups of water. Okay, so setting up a proportion, cross multiply, and solve. All right, so next topic we're going to talk about is exponents. So here's a big tip for you. You need to know your exponent rules. So your exponential rules are here. We have the product rule, the quotient rule, the power rule, the negative exponent rule, and the zero rule. So essentially, the product rule tells me that if I have exponents that have the same base, okay, the same base, in this case, it's a. If I'm multiplying those exponents, I just add the exponents. So here's a practical example, a to the second times a to the third. Well, that would equal a to the 2 plus 3, which is 5. Quotient rule is similar, But when we are dividing, instead of adding, we are subtracting. So a practical example, a to the 7th divided by a to the 3rd, 7 minus 3 would be 4, so a to the 4th. The power rule means if I have some exponent, so some power raised to another power, I need to multiply the exponents. So a to the 7th raised to the 2nd power would be a to the 7 times 2, which is 14. Our negative rule means if I have a negative exponent, in mathematics, we don't like to leave our negative exponents. We want a positive exponent in our final answer most of the time. So what we do is we push this to the bottom, put it into the denominator, and make it a positive. So a to the negative x would be the same thing as 1 over a to the x. Practical example would be a to the negative 4th would equal 1 over a to the 4th. Okay, and last but not least, our zero rule just means anything, any number to the 0 power is always 1. So this is a nice one to remember. All right, so let's look at a few examples of how we might use this. X to the 3rd times x to the 6th. So our rule here is to take the same base, and then we need to add our exponents. So x to the 3 plus 6 would give me x to the 9th. Okay, so that's our multiplication rule. Now let's try to do some division. A to the 3rd times b to the negative 2nd times c to the 4th, all over a to the negative 1st, b to the 3rd, and c to the 2nd. So important here that we can only use our rules with exponents that have the same base. So we're going to look at this in like 3 different parts. So division, we're going to subtract. So for this first one, a to the 3rd divided by a to the negative 1st would be a to the 3 minus negative 1. Okay, which is really just a to the 3 plus 1, which is a to the 4th. B to the negative 2nd over b to the 3rd would be b to the negative 2nd minus 3, which would give me negative 2 minus 3 is negative 5, b to the negative 5th. And then c to the 4th over c to the 2nd, 4 minus 2. That would give me c to the 2nd. Now, how do I write this with a positive exponent? Okay, what I do is I take the a to the 4th on the top, the b to the negative 5th, I push that to the bottom and make it positive, and then the c to the 2nd can stay on top. So there is my final answer. All right, our next example is a power to a power. So 5 to the 3rd raised to the 5th power means we need to multiply 3 times 5. 3 times 5 is 15. Okay, and then last but not least, 3 times x to the negative 4th. So 3 times x to the negative 4th, it's important to note that the negative 4th is only attached to the x here. This is very different than if I had written it with a parenthesis around it. Okay, so in this case, the first example I gave you, the 3 would stay on top and we would push the x to the negative 4th, we'd push that to the bottom and make it positive. If I had this in parentheses, this whole thing would have a negative 4 as an exponent, I would push this whole thing down to the bottom. So I could rewrite this as 1 over 3x to the 4th. And we could also write this as 1 over 3 to the 4th x to the 4th. Okay, so watch out for those parentheses in these types of questions. All right, so algebraic expressions is another topic that we need to be really comfortable with. So we may need to translate some sentences into algebraic expressions. We may need to simplify some algebraic expressions. So here are a few examples of what you might see. Translate the following into an algebraic expression. 3 times the sum of 4 and 5. So 3 times means I'm going to multiply 3 times something, and we're multiplying it by the sum of 4 and 5. So the sum of 4 and 5 just means 4 plus 5. Now, when we're doing 3 times that, we need to make sure we have our parentheses around it. So we do the sum of 4 and 5 first. So 3 times, right, the multiplication symbol is implied here, 3 times the sum of 4 and 5. What about this next one? 4 less than the product of 2 and 3 is 2. So 4 less than the product of 2 and 3. So the first thing you want to do is have the product of 2 and 3. So 2 times 3. And then 4 less than that means we have to subtract 4. So notice how we have to switch the order. It's written in one way, but when we do it algebraically, the minus 4 has to go at the end. And then a big key word here is is. Is means equals. So this equals 2. Okay, and lastly, let's simplify the following algebraic expression. 3a minus 4b plus 2 times a plus b. So first thing I want to do is get rid of these parentheses. So I'm going to distribute 3a minus 4b plus 2a plus 2b. Okay, and now I can combine like terms. 3a plus 2a, that would give me 5a. Negative 4b plus 2b would be negative 2b. So 5a minus 2b. All right, so linear equations is a topic that you may see in the QAS section. You may also see this in the AAF, in the algebraic, the advanced algebra functions section. Okay, so slope-intercept form and point-slope form are two things you need to know to write our linear equations. So slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. Point-slope form is written like this: y minus y1 equals m times x minus x1. So this is really helpful if you have one point and the slope, because the slope goes here, and then my 1 point is plugged into your x1 and y1. Okay, so let's see what an example might look like for a linear equations question. Find the equation of a line parallel to y equals 2x plus 5 that goes through the point 5, negative 3. So the equation of a line that's parallel to this line. So parallel lines have the same slope. So if I look at this equation, the slope is right here. The slope is 2. And then it goes through the point 5, negative 3. So if I know the slope and I know a point-slope form is the best option. So y minus y1 equals m times x minus x1. So what I can plug in is y minus my y value is negative 3 equals m, my slope is 2, times x minus 5. And then I'm just going to simplify y minus negative 3 to y plus 3 equals 2 times x minus 5. Okay, so this is the equation of a line. You could have also done y equals mx plus b, or slope-intercept form, but it would have been an extra step in there. So I would suggest using this form here. And then if you do need to get y by itself, we can just use this like an algebraic equation and distribute the 2 and then subtract 3 from both sides, and you can still get it into your slope-intercept form from here. Okay, so we also need to be comfortable with some linear applications and looking at graphs of linear functions. So in this example, we're given a graph. It says find the equation of a line perpendicular to this line that passes through the point 2, 3. So the equation of a line that is perpendicular to the line in the graph. So perpendicular lines have slopes that are negative reciprocals. So what does that look like? Reciprocal, something like that. Okay, so let's figure out the slope here. I see 2 points. To find the slope, I could plug it into my change in y over change in x, or I could just count my boxes. 1, 2, 3, 4. So I go down 4, and then to the right, 1, 2, 3, 4, 5. So my slope here is negative 4/5. The negative reciprocal of that would be to flip it and make it positive. So you change the sign and you flip it. So here is my new slope. And again, I'm given a point, so I'm going to use point-slope form. Y minus y1 equals m times x minus x1. So y minus 3 equals, my new slope is 5/4 times x minus 2. And then again, if you wanted to try, you could turn this back into our slope-intercept form if you wanted to. Okay? And here's an application problem of a linear function. At Benny's Cafe, a mixed green salad costs $5.75. Additional toppings can be added for 75 cents each. Find the function that could be used to determine the cost, C of S in dollars, of a salad with S additional toppings. And then we also need to find how much would a salad cost if you added 4 toppings. So a salad costs $5.75, and then you can add toppings for 75 cents each. So our function C of S is the cost of a salad. So the base cost, it starts at $5.75. Then you need to add 75 cents for every topping. So if I do 0.75 times the additional toppings, which we are labeling S, this will give me my function. And it is a linear function. It actually is in, if I rewrote this just a little bit, you would see it's in our slope-intercept form because this is my slope. And then my y-intercept would be 575. So either way you write it is fine. But that's just showing you that it's a linear function. So to find how much it would cost for 4 toppings, I can just plug in 4 for S. So 0.75 times 4 plus 575. So 0.75 times 4 is 3 plus 575. When I add that together, the cost of a salad with 4 toppings would be $8.75. All right, so let's get into some probability here. So what we really need to know for probability that we will not be given is how to find the formula. Probability equals a number of desired outcomes over the total number of outcomes possible. Okay, so good to know this. And you will see lots of different types of questions. Here is an example. So in a deck of 20 number cards, cards 1 through 5 are green, 6 through 10 are red, 11 through 15 are yellow, and 16 through 20 are blue. Describe the intersection of an odd number and blue cards. And then I have a few other questions that I added here. So the intersection of an odd number and blue cards. Intersection means one that would be in both categories. So we need something that's an odd number and also blue. So blue cards go 16 through 20. So odd ones in that list would be 17 and 19. That would be the intersection, just these 2 cards, the only ones that are in both of those groups. Okay, what is the probability of pulling a card? Well, red cards are 6 through 10. So that's 5 options, 6, 7, 8, 9, 10. So 5 out of the 20 cards. So 5 out of 20, or I could write this as 1 over 4. What is the intersection of green cards and even numbers? Well, intersection again means it has to be in both. So green cards are 1 through 5 and even numbers are only 2 and 4 in that list. And then the last question, what is the union of yellow and blue cards? So union means that we are combining them. Okay, so union of yellow and blue cards. So the yellow cards, which are 11, 12, 13, 14, and 15. And the blue cards, which are 16, 17, 18, 19, 20. So the union here would be any of the yellow cards, which I've listed here, and any of the blue cards, which I've listed here as well. Okay, so a few probability questions. Another topic that we're going to do is the descriptive statistics topic. So what that means is finding statistics often is the mean, median, mode range, and interquartile range. So that's what we're going to try to find in this example down here. The following table shows the heights in inches of players on the opening night roster of the 2015 to 2016 New York Knicks. So we're going to find everything I listed above. So to find the mean, you need to find the average. So mean should make you think of average. So what we need to do to find the average is add all of these up and divide by the number of pieces of data there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So adding them all up, just plug them in your calculator nice and carefully. And when you add them up, you should get 1,036. And then we're going to divide that by 13. And let's just round to the nearest whole number. Okay, so the nearest inch would give me approximately 80 inches as my mean. So that is my average. If I need to find the median, I'm going to take my data, and the first thing I need to do is put it in order because I'm going to try to find the middle number. So median should make you think of middle. So I'm going to put these in order. From least to greatest. That's how I'm going to do it. So 74 is the smallest one that I see. So I'm going to start with that. So 74. And then I'm just kind of scanning through and crossing them off as I go so I don't forget any. When you have a paper test or something that you can mark up like this on the computer, I find this to be really helpful. So just bear with me while I go through, and I'm going to try to do this carefully so I don't forget. 1, 2, 3, 4. There's 4 80s. 2, 3, 4. And then it looks like there's two 82s. And then we've got an 84 and an 87. So I'm going to double check and make sure I have 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now to find the median, what I do is I cross off the smallest number and then the largest, and I keep going until I get to the number that's in the middle. So here in this case, our median lands right on 80. So my median is 80. So that's an interesting find, is that the mean and the median are actually the same. Now, if we have to find the mode, we're looking for the one that happens the most often. So mode MO, think of most often. And the way that I listed them before, notice how I wrote 84 times. That was definitely the most. So 80 is also my mode. Now the last two, range and interquartile range. Range is just going to be the max minus the min, so the largest minus the smallest. 87 minus 74 in this case would give me 13 as my range. And the last one we are going to do for this statistics question is to find the interquartile range, or IQR. So if you remember box and whisker plots, or what we call the 5-number summary, this is something that we may have seen in previous math courses, but I'll show you a quick way to do this. So we already split this in half, this data, by finding the median. So the interquartile range means I need to find my quartile 3 and subtract my quartile 1, and that range is what I'm looking for. So what I'm going to do is I'm going to look for quartile 3 by doing the same thing I did for the median, cross off the highest and the lowest, and I end up with 82 and 82. So if those were the same number, which they are, then the answer is just 82. If they were different, then I would have to find the average of the two. So let's do the same thing for this section and see how 76 and 77, I'm looking for what's right in the middle, or the average, which would be 76.5. So if I take 82 and subtract 76.5, that is going to be my interquartile range, which should be 5.5. Okay, so there are some important topics that you want to be comfortable with in statistics. Our last topic for this video is geometry. So the geometry concepts we want to be familiar with for the Accuplacer are volume, area and perimeter, surface area, and also transformation. So I'm not going to do all of those in this video. If you want a specific topic in here that I don't do, you want questions on that, leave a comment below so I can come back and do questions that you are looking for. So here's an example. 2 rectangular rooms need to be carpeted. The dimensions of the first room are 18 by 19 feet, and the dimensions of the second room are 12 by 10 feet. What is the total area to be carpeted in square feet? So I have 2 rooms, and I need to find the total area. So area of our rooms is going to be length times width. So for one, I'm going to do 18 times 19, and the other, I'm going to do 12 times 10. So I'm going to go ahead and plug this in. 18 times 19, I get 342. 12 times 10, I get 120. Now the total area to be carpeted, I'm going to add these together. So 462 looks like my total area. Okay. And here's a circle question. The circumference of a circle is 45 inches. Find the area of the circle in square inches, round to the nearest tenth, and use 3.14 for pi. So 2 formulas we want to know for circles here in geometry. Circumference equals pi times diameter, and area equals pi times the radius squared. So you may have also seen circumference as 2 pi r, 2 pi times the radius. Both of these are the same. You can choose which one you like, or depending on the question, one might be more helpful. So if I know the circumference of a circle is 45, I can plug that in for C. And we're using 3.14 for pi. And eventually we're going to need to find the area. So I could plug it into this formula here and find the diameter and then use that to plug it in later, or I could plug it into this formula. I'm just going to leave this here for D and then go from there. So in order to find the diameter, I divide each side by 3.14, and I find that my diameter is approximately 14.33, somewhere around there, depending on how you round it. So if that's my diameter, my radius is going to be half that. So I just divide that by 2 and I get 7.165. So I'm just going to leave it like that for now. I can plug into my calculator to make this a little bit easier. So now with my area, 3.14 for pi, 7.165 is my radius, and I need to make sure I square that. So if I plug this into my calculator, I get approximately 161.198, something like that. And because we're rounding here, our answers may not be exact because the way that they did this question may have rounded a little differently. So I'm just going to look for the one that's closest to this. And by far, 162.8 is the closest answer. That's very reasonable. That makes sense. So sometimes you won't get the exact answer because of rounding with some of these questions when we're talking about pi or having a round, but we can just choose the option that works best. Okay, so that is the last question we have for this video. Again, if you have specific questions you want me to go over, please leave a comment at the bottom of this video. And remember to check out the links in the description for more questions to practice and free online practice tests and our full online course. Okay, hope this video was helpful and I will see you in the next one.